How America Assembled a Bomber. Every hour at Willow Run, January 17, 1941. Coronado Hotel, San Diego, California. Charles Sorensen stared at papers scattered across the floor of his hotel room, each stack representing a different sub-assembly of the most complex aircraft ever designed for mass production. The vice president of production for Ford Motor Company had spent the entire night doing what aircraft industry experts said was impossible, sketching an assembly line that would produce one 4-engine B-24 Liberator bomber every single hour. Outside his window, the Pacific Ocean stretched toward a war that was pulling America closer with every passing week. Inside, Sorensen's pencil scratched across Coronado Hotel notepaper, outlining a factory that would be 1 mile long and a 1/4 mile wide. The aviation industry would mock this vision. "You can't expect a blacksmith to make a watch overnight," they'd say. But in 42 months, Ford would build 8,685 B-24 bombers at Willow Run, more than half of all Liberators produced, proving that American industrial democracy could outproduce anything the Axis powers could imagine. In January 1941, the United States military possessed 1,700 combat aircraft. No heavy bombers. This ranked America as the 18th strongest air force in the world, behind Romania. President Franklin Roosevelt had shocked the nation during his May 1940 fireside chat, demanding 50,000 combat aircraft within 12 months. His goal exceeded every airplane built in America since the Wright brothers' first flight at Kitty Hawk in 1903. The aviation industry couldn't meet this demand. Consolidated Aircraft in San Diego built B-24 Liberators by hand, outdoors, on steel fixtures that warped in the California sun. It took them 4 hours just to hang a single engine. They produced 1 bomber per month. At this rate, America would lose the war before it officially began. The B-24 Liberator represented everything aviation engineers believed couldn't be mass-produced. 67 feet long with a 110-foot wingspan. 4 Pratt & Whitney R1830 engines generating 1,200 horsepower each, 30,000 separate components, 450,000 parts, 360,000 rivets in 550 different sizes, 18 tons of aluminum, steel, and rubber. The bomber dwarfed anything Ford had ever manufactured. A Ford V8 automobile contained 15,000 parts and weighed 3,000 pounds. The B-24 was 30 times more complex. "You're comparing a garage to a skyscraper," industry veterans warned Sorensen. But Sorensen saw something they didn't. He saw the fundamental principles of mass production: break complex products into standardized units, build them in parallel, then bring them together on a moving assembly line. The same principles that let Ford produce 10,000 cars per day at River Rouge. The same principles that had revolutionized American manufacturing. The same principles that, if applied to aircraft, could change the course of the war. The stakes couldn't be higher. Germany's Luftwaffe dominated European skies. Britain stood alone, bleeding under nightly bombing raids. If America couldn't deliver heavy bombers in massive numbers, the Allies would fall. And if the Allies fell, democracy would fall with them. Sorensen knew the experts would ridicule him. He knew aircraft manufacturers would resist. He knew even his own company's engineers would doubt. But on that January night in San Diego, Charles Sorensen made a decision that would reshape modern warfare. He would build a factory unlike anything the world had ever seen. He would prove that American mass production could manufacture anything, even flying fortresses. He would show Adolf Hitler that when America's industrial machine shifted into high gear, no enemy could match it. The visit that changed everything. Charles Sorensen arrived at Consolidated Aircraft's San Diego plant, expecting precision. Instead, he found chaos. Workers assembled B-24s outdoors under the open California sky. Steel fixtures, exposed to temperature swings from day to night, expanded and contracted constantly. Surveyors used transit equipment mounted on pickup truck pallets to align propeller shafts, a method accurate to mere inches, not the thousandths required. No two aircraft were identical. Wing sections built in one area didn't fit fuselages built in another. Engineers made constant adjustments, filing parts by hand, forcing components together. Quality control was reactive, not preventive. Reuben Fleet, Consolidated's president, defended the operation. "We've always built aircraft this way," he explained. "This is craftsmanship." Sorensen watched a team spend an entire afternoon installing one engine. 4 hours for a single engine. 16 hours to install all four. At this pace, one complete bomber required 3 to 4 weeks. This should have been impossible, Sorensen thought, except it wasn't just possible, it was normal for the aircraft industry. That night, back at the Coronado Hotel, Sorensen couldn't sleep. The images of outdoor assembly, warped fixtures, and handcrafted adjustments haunted him. He began sketching, not complicated blueprints, just simple pencil drawings on hotel notepaper. He listed every major unit of the B-24, fuselage, wings, tail assembly, landing gear, engines, turrets. Then he broke each major unit into subunits, then subunits into individual components. Soon, papers covered his hotel room floor in organized stacks. Each stack represented one assembly station. He calculated timing for each operation. He estimated required floor space. He mapped the progression from raw materials to finished bomber. By 4 o'clock in the morning, Sorensen had it. A factory 1 mile long and a quarter-mile wide. The largest single building ever constructed. An assembly line that would move B-24s through standardized stations, adding components at precisely timed intervals. One bomber every hour. The sketch, which Sorensen would later have Edsel Ford, Henry Ford, and other executives initial, outlined the true Willow Run, not the facility that would struggle through 1942 and early 1943, but the industrial colossus that would eventually emerge. The promise, when Sorensen presented his plan to Army Air Corps officials, silence filled the room. Major General George Brett studied the pencil sketches. 1 bomber per hour, he asked quietly. Every hour, 24 hours a day, 7 days a week, Sorensen confirmed. The aviation industry representatives present laughed openly. Dutch Kindleberger, president of North American Aviation, shook his head. "A blacksmith can't make a watch overnight, Mr. Sorensen." But Major General Brett wasn't laughing. He understood mathematics. At Consolidated's current pace, 30 bombers per year from their San Diego plant. At Sorensen's proposed pace, 8,760 bombers per year from one facility, the difference between defeat and victory. In February 1941, Ford Motor Company received a contract worth millions of dollars, not to build B-24 components, to build complete bombers, to construct the factory, to prove that American industrial might could mass-produce anything, even flying fortresses. Building the unbuildable construction began in March 1941 on flat Michigan farmland near Ypsilanti. Henry Ford owned the land, 975 acres of former soybean fields along Willow Run Creek. Architect Albert Kahn translated Sorensen's hotel sketches into reality. The main structure would contain 3.5 million square feet under one roof. Some accounts suggest the total complex reached nearly 5 million square feet when including all facilities. The building stretched over a mile in length, a quarter-mile in width. To accommodate local property boundaries and the planned airport, Kahn designed an L-shaped layout with a distinctive 90-degree turn in the assembly line. The turn itself became an engineering marvel. Massive turntables allowed aircraft to rotate without stopping production flow. 6 months and $47 million later, Ford opened the Willow Run bomber plant. The plant featured assembly lines running in parallel. Dual lines meant redundancy. If one stopped, production continued. The factory was divided into specialized zones. Wing assembly in one section, fuselage construction in another. Tail sections, landing gear, engines and turrets each had dedicated production areas. Components moved toward 2 central assembly lines where complete bombers took shape. At the end, 6 runways and 3 massive hangars. The largest hangar could house 20 B-24s simultaneously and included a control tower, cafe and hotel for test pilots. Adjacent to the plant, the government funded unprecedented infrastructure. A new expressway, America's second interstate highway, now I-94, connected Willow Run to Detroit. The Willow Run Expressway included a revolutionary tri-level interchange providing direct factory access. The federal government spent $20 million constructing Willow Village, 30 dormitories, 6 community buildings, rows of small houses, schools, police and fire stations, medical facilities, housing for more than 15,000 workers and their families. The scale was staggering, but scale meant nothing if the factory couldn't deliver. The disaster, September 1942. The first Ford-built B-24 Liberator rolled off the Willow Run line. Reporters, military officials, and Ford executives gathered for the ceremony. Flashbulbs popped, newsreel cameras rolled. The bomber sat gleaming in Michigan sunlight. Then Army Air Corps inspectors climbed inside. What they found shocked everyone: rivets improperly installed, wiring harnesses misrouted, hydraulic lines leaking, control surfaces out of alignment. The bomber was designated for training only, unfit for combat. By the end of 1942, Willow Run had produced only 56 B-24s. All were rejected for combat service. The media, which had breathlessly reported Ford's promise of a bomber a minute, turned viciously critical. Newspapers began calling the facility Will It Run. Editorial cartoons showed bombers falling apart on assembly lines. Aviation industry executives felt vindicated. "We told them a blacksmith can't make a watch," they said. But the disaster had specific causes. Charles Sorensen had anticipated building bombers from detailed engineering drawings. Instead, Consolidated provided sketches, templates, and verbal instructions. Much of the actual B-24 design existed only in the memories of Consolidated plant foremen. Sorensen had 2 complete Liberators flown to Dearborn, Michigan. Ford engineers disassembled them piece by piece. A 1,000-member tool design group worked around the clock, 7 days a week, for almost a year. They created 3-dimensional schematics of the plane's 30,000 components. They generated 5 million square feet of blueprints, 5 miles of drawings every single day. But Consolidated continued making design changes. Every change invalidated drawings. Every change required retooling. 10,000 of the 30,000 engineering drawings became obsolete before Ford could use them. All the tooling they designed now doesn't work because Consolidated changed the airplane every day. Historians would later document. This created a 6-month delay in the production schedule. Quality problems emerged from Ford's automotive-focused approach. Engineers designed steel dies perfect for stamping car parts, but too inflexible for aircraft modifications. Workers accustomed to automotive tolerances struggled with aircraft precision requirements. Ford supervisors, trained in automobile production, didn't understand aircraft systems. The plant's location created additional problems. 35 miles from Detroit, No existing highway connections when the plant opened. Workers faced hour-long commutes on rural roads. Gasoline and tire rationing made travel difficult. Housing shortages plagued the area. In 1 month, Ford hired 2,900 workers, but lost 3,100. High absenteeism rates and rapid turnover crippled production. The plant was designed for 100,000 workers. Employment peaked at 42,000, less than half capacity. Labor relations deteriorated. Henry Ford's opposition to unions created constant friction. Wildcat strikes interrupted production. Management battles distracted from actual bomber building. And through all this chaos, Consolidated retained partial control over design changes. The Army Air Corps made constant modification requests, new turret designs, updated armament configurations, improved armor protection, self-sealing fuel tanks. Each modification meant production line shutdowns. Each shutdown meant missed quotas. Each missed quota meant more pressure. More pressure meant more mistakes. By February 1943, the situation had become critical. The investigation Senator Harry S. Truman walked through Willow Run in February 1943. As chairman of the Senate Special Committee to investigate the National Defense Program, Truman had authority to shut down failing war production facilities. Some government officials were discussing nationalizing Ford Motor Company, taking Willow Run away from Ford entirely. Truman expected incompetence. He found something else. Charles Sorensen and Edsel Ford walked the senator through every production stage. They showed him the engineering drawings, the constant design changes from Consolidated, the daily phone calls demanding modifications, the tooling that became obsolete before it could be used. Truman interviewed workers, he examined aircraft components, he reviewed production schedules and change orders. His conclusion shocked Washington. Ford wasn't the problem. Consolidated's ongoing design authority was strangling production. The Truman Committee's report gave Willow Run a clean bill of health. It called for one decisive change: a single plant manager with absolute authority over daily operations. No more dual control, no more daily design changes, no more competing priorities from Consolidated and the Army. From that moment forward, Willow Run's plant manager made all operational decisions. The transformation began immediately. The breakthrough spring 1943 marked the turning point. Ford negotiated a new arrangement with the Army Air Corps. Design changes would be batched, not implemented daily. Willow Run would focus on predictable production runs of standardized variants. Field modification centers would handle customization and updates after bombers left the factory. This allowed continuous assembly flow, the fundamental requirement for mass production. Sorensen's team refined the assembly process. They broke the B-24 into 11 major assemblies. These divided further into 69 sub-assemblies. Each sub-assembly had a dedicated production line feeding into the main assembly. The center wing assembly became the key to hitting production targets. All prefabricated structures were pre-manufactured to precise tolerances. Components snapped into place without filing or forcing. Riveters knocked wing parts together in coordinated teams. Then the center wing assembly moved to a multi-function machine, completing 42 precision machining operations to within 0.002 inches in just 17 minutes. This level of precision allowed true interchangeability. Any fuselage could mate with any wing. Any tail section fit any fuselage. Any engine nacelle attached to any wing. The mathematics of mass production finally applied to aircraft. Worker training improved dramatically. The Aircraft Apprentice School trained up to 8,000 students per week. New hires sat through orientation lectures on the aircraft industry. the B-24's strategic importance and the consequences of Allied defeat. Specialized training turned raw recruits into skilled workers. Riveters practiced on mock-ups until they could drive rivets perfectly. Welders trained on scrap sections before touching actual aircraft. Quality inspectors learned to spot defects before components reached final assembly. And the workforce transformed in another remarkable way. Rosie the Riveter. Rose Will Monroe moved from Pulaski County, Kentucky to Michigan in 1943. A widow with 2 young children, she needed work. Willow Run paid 85 cents per hour for 9-hour shifts, excellent wages by 1940s standards. Men and women earned identical pay for identical work. By May 1942, women comprised 15% of the Willow Run workforce. By 1944, that number reached 40%. 12,000 women worked at Willow Run during peak production. They operated rivet guns, drill presses, and welding equipment. They climbed into cramped spaces men couldn't access. They assembled delicate instruments and heavy structural components. Before World War II, it was commonly believed that women were too emotionally fragile to work in factory environments, one historian noted. Rosie the Riveters proved that theory catastrophically wrong. Rose Monroe caught the attention of Hollywood producers filming a war bonds promotional video. A song called Rosie the Riveter was already popular on radio. Finding an actual woman named Rose working as a riveter seemed providential. Monroe appeared in the film. Her image inspired the famous "We Can Do It" poster. She became the face of American women in wartime industry. But Monroe represented thousands of women whose contributions enabled Willow Run's success. Women like Norma Denton, photographed on February 10, 1943, riveting airplane panels. Women like Eleanor Otto, who began riveting aircraft in 1942 and continued for 50 years, finally retiring at age 95. Women whose names history didn't record, but whose work won the war. The rivet guns they operated weighed 15 to 20 pounds. Workers held them overhead for hours. The physical demands matched or exceeded traditional male factory work. Salt tablets were distributed so workers didn't have to leave their stations during 9-hour shifts. The pace was relentless, but the women kept pace. Ford personnel managers scoured the country for workers of all kinds. They hired African Americans in significant numbers, unusual for the era. They recruited little people from circuses and elsewhere to rivet and assemble components in extraordinarily tight crawl spaces inside the fuselage and wings. The workforce became remarkably diverse. Southern migrants, urban factory workers, rural farmers, women entering industrial work for the first time, African Americans gaining unprecedented manufacturing opportunities. All united by one goal: get bombers into the sky. The rhythm. By mid-1943, Willow Run found its rhythm. The assembly line moved at a calculated pace. Stations were timed to the second. Components arrived at precisely the moment workers needed them. No waiting, no searching for parts. Everything flowed. A fuselage entered the line as a bare aluminum shell. Station by station, it transformed. Bulkheads installed, wiring harnesses threaded through. Hydraulic lines connected. Control cables routed and tensioned. Fuel cells positioned and sealed. Meanwhile, wings took shape on parallel lines. The distinctive Davis wing, high aspect ratio, low drag, required extreme precision. Ribs were positioned exactly. Spars aligned perfectly. Skin panels riveted with absolute consistency. 450,000 rivets per aircraft. Teams of riveters worked in synchronized patterns. One positioned the rivet. Another drove it with the pneumatic gun. A third checked for proper installation. The sound was thunderous. Thousands of pneumatic rivet guns firing simultaneously. It was the sound of freedom being hammered together. One worker recalled. Engines arrived from Buick Motor Division, which produced the Pratt & Whitney R1830 Twin Wasp under license. Each engine was test-fired before installation. 1,200 horsepower screaming through the Willow Run test cells. 4 engines per bomber. The engines weighed 1,450 pounds each. Installing them required precision hoists and experienced mechanics. At the peak of efficiency, engine installation took less than 1 hour per aircraft, a far cry from Consolidated's 4 hours per engine. Tail assemblies, nose sections, bomb bay doors, landing gear, turrets, all converged on the main assembly lines. The B-24 came together like a massive puzzle with 488 193 pieces. By early 1944, the system achieved maturity. 1 bomber every 63 minutes, April 1944. 28 months after the first problematic B-24E rolled off the line. 25 months after the Willow Run mockery began. 10 months after the Truman Committee investigation. Willow Run produced 453 aircraft in 468 hours during April 1944. The mathematics were stunning: 1 complete B-24 Liberator every 63 minutes on average. Actually, peak production achieved 1 bomber every 55 minutes. Faster than Sorensen's original impossible promise. Charles Sorensen's hotel napkin sketch had become measurable reality. At peak production, 1 bomber left Willow Run every 55 minutes. 24 hours a day. 7 days a week. The assembly line never stopped. Workers operated in 2 9-hour shifts, 6 days a week, 18 hours of staffed operations daily, with skeleton overnight crews for security and maintenance. During shift changes at 6 a.m. and 3 p.m., one team briefed the next on the exact status of each aircraft in progress. Aircraft 4,327, fuselage complete, waiting for wing attachment in 15 minutes. Aircraft 4,328, wiring harness installation at 75% on schedule. Aircraft 4,329, hydraulic system pressure test failed, repair team assigned. Continuity was absolute. No aircraft waited, no station stood idle. Production flowed like a river. Outside, pilots and flight crews waited on 1,300 cots in the massive hangar for new bombers. Some slept, some played cards, some wrote letters home. All waited for their assigned aircraft to complete. Each aircraft that rolled off the line went directly to the test runway. Test pilots conducted acceptance trials, full-throttle engine runs, all 4 engines at maximum power, checking for vibration or overheating. Control surface checks, moving ailerons, elevators, rudder through full range of motion. Taxi tests, ground handling characteristics at various speeds. Then flight tests, typically 30 minutes minimum. Takeoff performance, confirming the bomber could lift 65,000 pounds safely. Climb rate, verifying the aircraft could reach combat altitude. Level flight characteristics, testing stability and control response. Landing, the most critical phase, especially with the B-24's challenging handling. If problems emerged, mechanics addressed them immediately. A team of specialists waited at the runway for exactly this purpose. Engine running rough, spark plug change, magneto adjustment, carburetor tuning, often fixed in 30 minutes. Control surface binding, adjustment of cables, lubrication of pulleys, realignment of mounting points. Most aircraft passed testing on the first attempt. The quality improvements from systematic inspection meant problems were rare by the time aircraft reached flight testing. Those that passed flew to field modification centers, specialized facilities where bombers received theater-specific modifications. European theater B-24s got additional armor and cold weather equipment. Pacific theater B-24s received long-range fuel tanks and tropical climate modifications. Or bombers flew directly to operational units. The 1st Concentration Command operated from Willow Run Airport, completing the organization and equipment of bombardment squadrons before deployment overseas. New crews arrived, received their aircraft, flew training missions over Michigan, then departed for combat theaters. By June 1944, Willow Run had the capacity to produce 650 B-24s per month. But the Army Air Corps ordered production slowed to 200 per month. "We have no place to park them," officials admitted. "The losses in combat haven't been what we expected." American air superiority had become so complete that bomber losses fell below projected replacement needs. The Luftwaffe could no longer mount effective defense. German fighter production couldn't replace losses. Fuel shortages grounded aircraft. Experienced pilots were dead. Replacements had minimal training. American bomber formations operated with near impunity over German skies by mid-1944. The production problem had reversed completely. Not too few bombers. Too many. Willow Run had solved the problem so thoroughly that it exceeded military needs. The bomber, the B-24 Liberator that rolled off Willow Run in April 1944, represented the pinnacle of Ford's industrial achievement. Wingspan, 110 feet, wider than most factory buildings. Length, 67 feet 2 inches, longer than a bowling lane. Height, 18 feet, as tall as a 2-story building. Empty weight, 37,000 pounds, 18.5 tons of aluminum, steel, rubber and equipment. Maximum takeoff weight, 65,000 pounds, 32.5 tons fully loaded. 4 Pratt & Whitney R1830-65 twin Wasp engines, 14-cylinder air-cooled radial engines, having 200 horsepower each, 4,800 total horsepower. 3-bladed propellers, 11 feet in diameter. Maximum speed, 290 miles per hour at optimal altitude, faster than many fighters of the era. Combat operating speed, 180 to 215 miles per hour at 10,000 to 25,000 feet, where most bombing missions occurred. Cruise speed, 215 miles per hour for maximum fuel efficiency on long missions. Service ceiling, 28,000 feet, though some missions flew at 30,000 feet with reduced bomb loads. Range, 2,900 miles with maximum bomb load, enough to reach targets deep in Germany from English bases. Maximum range, 3,500 miles, for long over-water missions in the Pacific. Fuel capacity, 3,614 gallons in fuselage and wing tanks. Bomb capacity, 8,000 pounds in 2 separate bomb bays, typically 8 1,000-pound bombs, or combinations of smaller ordnance. Some missions carried 12,800 pounds of bombs for shorter-range targets. Crew, 10 men on typical missions. Pilot, aircraft commander responsible for entire crew. Co-pilot, assists pilot, takes over if pilot is wounded. Bombardier, operates Norden bomb site, releases bombs. Navigator, plots course, calculates winds, ensures aircraft reaches target. Radio operator, maintains communication with base and other aircraft. Flight engineer, monitors engines and systems, makes in-flight repairs. Nose turret gunner, 250 caliber machine guns, defends against head-on attacks. Top turret gunner, 250 caliber machine guns, positioned just behind cockpit. 2 waist gunners, 150 caliber machine gun each, positioned on opposite sides of aft fuselage. Ball turret gunner, 250 caliber machine guns, most dangerous position, suspended below fuselage. Tail gunner, 250 caliber machine guns, defends against attacks from rear. Total armament, 10 Browning M2, 50 caliber heavy machine guns, each gun capable of firing 800 rounds per minute. Effective range, 1,000 yards. The B-24 carried more bombs farther and faster than the B-17 Flying Fortress. Higher speed gave less time for enemy fighters to attack. Greater range allowed strikes against targets B-17s couldn't reach. Higher bomb capacity meant more destruction per mission, but it was more difficult to fly than the B-17. Heavy control forces made the B-24 physically exhausting for pilots. Formation flying required constant attention. The B-24 didn't naturally maintain altitude and position like the B-17. The high-mounted Davis wing provided excellent performance but made ditching in water extremely dangerous. The wing would catch and flip the aircraft. Fuel tanks positioned in the upper fuselage made the aircraft vulnerable to fire. A direct hit often resulted in catastrophic fuel fires. Many B-24 crews grimly called their bomber the flying coffin. Combat loss rates for B-24s exceeded B-17s in European operations. Yet the Liberator served in every theatre of World War II with distinction. European theatre, strategic bombing of German industry, transportation and oil facilities. The combined bomber offensive that destroyed Germany's industrial capacity. Pacific theatre, long-range strikes against Japanese bases, shipping and industrial targets. The island-hopping campaign required aircraft that could cover vast ocean distances. Mediterranean theatre, attacks on Axis oil facilities, particularly the famous August 1, 1943 raid on Ploiești, Romania. 178 B-24s attempted to destroy 9 oil refineries supplying Germany. China-Burma-India theatre, supply missions over the hump. The Himalayan air route was the only way to supply Chinese forces after Japan cut land routes. Atlantic theatre, anti-submarine patrols closing the mid-Atlantic gap. Very long range, VLR. Liberators hunted U-boats where other aircraft couldn't reach. Liberators were credited with sinking 93 U-boats. More than 18,000 B-24s were built by war's end. Ford's Willow Run produced 8,685, 47% of the total, plus 1,893 knockdown kits shipped to Douglas Aircraft in Tulsa and consolidated in Fort Worth for final assembly. Total Willow Run production, 10,578 complete aircraft equivalents. The B-24 holds the distinction of being the most produced American military aircraft in history. More B-24s were built than any other American aircraft, bomber or fighter, during World War II. The assembly line had created an aerial armada. The human cost success came with a price. Edsel Ford, president of Ford Motor Company and steadfast supporter of the Willow Run project, died on May 26, 1943. Officially, cancer killed him. But those close to Edsel understood the enormous stress of Willow Run had affected his health. The constant pressure, the criticism and mockery during early production problems, the responsibility of proving his vision correct. Edsel never saw Willow Run reach peak production. He never witnessed the plant achieve 1 bomber per hour. He died while the factory was still fighting through its difficulties. Charles Sorensen, despite his central role in Willow Run's success, retired from Ford in March 1944. The same month Willow Run began producing B-24Js, the most advanced variant Ford would build. Sorensen had spent 40 years with Ford. He'd developed the moving assembly line. He'd overseen River Rouge. He'd conceived and built Willow Run. But by 1944, conflicts with Henry Ford and Harry Bennett made his position untenable. Sorensen accepted the presidency of Willys Overland, overseeing its transition from wartime to peacetime production. He never returned to Ford. Thousands of workers experienced the war's human cost more directly. Sons and husbands of Willow Run workers died in bombers built in that Michigan factory. The aircraft they built carried their own family members into combat. Some workers lost multiple relatives. They kept building. Because stopping meant more American deaths, more Allied defeats, more months or years of war. They built through grief, through exhaustion, through winter cold and summer heat. They built because the mathematics were clear. More bombers meant fewer casualties. More production meant shorter war. More aircraft meant sons coming home. The comparison: while Willow Run produced 8,685 B-24s, Germany's entire aircraft industry struggled. The Messerschmitt Bf 109, Germany's primary fighter, had a total production run of approximately 34,000 aircraft. Impressive, except that was spread across 1937 to 1945. 8 years of production. The Focke-Wulf FW 190 fighter, approximately 20,000 produced from 1941 to 1945. The Junkers Ju-88, Germany's most produced bomber, approximately 15,000 from 1939 to 1945. Germany's legendary Messerschmitt Me 262 jet fighter, only 1,430 produced. German production faced constant Allied bombing. Factories operated underground. Supply lines were interdicted. Fuel shortages limited operations. By 1944, Germany produced excellent aircraft but couldn't field them effectively. They lacked fuel. They lacked trained pilots. They lacked the industrial capacity to replace losses. Meanwhile, American factories churned out aircraft at rates German planners called impossible. In 1944 alone, American industry produced 96,000 aircraft. Germany produced 40,000. Japan produced 28,000. The mathematics of industrial warfare were brutal and decisive. American production capacity exceeded the combined output of all Axis powers, and Willow Run embodied that superiority. One factory in Michigan produced half as many heavy bombers as Germany's entire Luftwaffe produced of all types in 1943. The assembly line had become a weapon more powerful than any bomb. The legacy. The last B-24 Liberator rolled off the Willow Run line on June 28, 1945. The war in Europe had ended on May 8. Japan would surrender on August 15. Willow Run had accomplished its mission. By the numbers, total B-24s produced at Willow Run, 8,685. Complete aircraft, 6,792. Knockdown kits, 1,093. Total aluminum used, 92 million pounds. Total production span, June 1942 to June 1945. Peak employment, 42,000 workers. Peak production rate, one bomber every 55 minutes. Total cost per B-24, approximately $300,000. German equivalent heavy bomber cost, nearly $1 million. American cost advantage allowed 3 B-24s for every one German heavy bomber. But the legacy extended far beyond numbers. Willow Run proved that American industrial methods could manufacture anything at scale. The techniques refined at Willow Run influenced post-war manufacturing worldwide. Toyota studied Ford production systems after the war, developing just-in-time and lean manufacturing principles directly from Willow Run's methods. Modern assembly line management traces its sophisticated methodologies to lessons learned building bombers in Michigan. The social legacy proved equally significant. Women who worked at Willow Run gained skills, confidence, and economic independence. Many never returned to traditional domestic roles. They'd proven they could do men's work, and do it superbly. The foundation for 1960s and 1970s women's labor movements was built in part by Rosie the Riveters. African Americans who found employment at Willow Run experienced industrial opportunities previously denied. The plant's diverse workforce challenged assumptions about who could perform skilled labor. After the war, Kaiser Frazer Corporation purchased Willow Run, producing 739,000 automobiles from 1947 to 1953. General Motors then leased and later purchased the facility, operating it until 2010. Most of the massive complex was demolished in 2013 and 2014, but a 175,000 square foot section was preserved. The Yankee Air Museum now occupies part of the historic building, ensuring that future generations can understand what happened there. The remaining site became the American Center for Mobility, a proving ground for autonomous vehicles. 75 years after Willow Run built bombers, the site developed self-driving cars. from mass production to advanced automation, from wartime necessity to peacetime innovation, the spirit of Willow Run endures. Epilogue: The fundamental truth. Charles Sorensen's hotel room sketch on January 17, 1941, contained a fundamental insight. Mass production isn't limited by product complexity. It's limited by vision. The aviation industry saw a complex aircraft and declared it impossible to mass produce. Sorensen saw 488,193 parts and recognized that each part could be standardized, manufactured in parallel, brought together on a moving line. The expert saw craftsmanship. Sorensen saw industry. The experts saw individual artisans shaping unique aircraft. Sorensen saw synchronized systems creating identical products. The difference determined the war's outcome. Germany had excellent engineers, skilled workers, and advanced designs. But Germany lacked America's industrial philosophy. The Luftwaffe built aircraft as individual projects. America built them as industrial products. The mathematics overwhelmed everything else. One Willow Run outproduced Germany's entire heavy bomber industry. The assembly line didn't just build aircraft faster, it built them better, because standardization enabled quality control impossible with handcrafted production. It built them cheaper, because economies of scale reduced per-unit costs. It built them in numbers that made victory inevitable. By 1944, Allied air superiority was absolute. German pilots looked at the sky and saw endless streams of American bombers. Formations so large they darkened the sky. Bombers produced so quickly that losses were irrelevant. For every B-24 shot down, 3 more rolled off Willow Run's lines. The mathematics of attrition favored whoever could build fastest. America could build fastest. Willow Run proved it. The bomber plant on former soybean fields in Michigan represented something deeper than industrial achievement. It represented the power of democratic capitalism to outproduce totalitarian systems. It represented the American genius for logistics, organization, and scale. It represented the willingness of ordinary citizens to transform themselves into whatever the moment demanded. Farmers into factory workers, women into riveters, racial minorities into skilled technicians. The pencil sketch Charles Sorensen drew on Coronado Hotel notepaper wasn't just a factory design, it was a blueprint for victory. 1 bomber every 63 minutes, 8,685 aircraft in 3 years. Half of all B-24s produced, the assembly line that won World War II. When historians study the Allied victory, they examine battles and generals, strategies and weapons. But the true story is simpler. America won because America could build faster, and Willow Run built fastest of all. The massive factory that critics called Will It Run became the arsenal of democracy's crowning achievement. The experts who said a blacksmith couldn't make a watch learned a harder lesson. When American industry fully committed to a goal, nothing was impossible. Not even building flying fortresses on a moving assembly line. Not even producing 1 bomber every hour. Not even winning a war through sheer industrial might. Willow Run didn't just assemble bombers, it assembled victory. 1 rivet at a time, 1 worker at a time, 1 bomber every 63 minutes, until the war was won.